When people talk about energy, they usually mean how alert, motivated, or productive they feel. They talk about energy as a feeling. But inside the body, energy has a much more precise meaning. Energy is not motivation. It is not stimulation. And it is not a mood. Energy is a cellular process. At the most basic level, the body runs on a molecule called ATP, adenosine triphosphate. ATP is the unit of usable energy. Every movement you make, every thought you have, every heartbeat, and every repair process in the body depends on ATP being produced continuously. If ATP production slows down, the body doesn't negotiate. It reduces output. That reduction is what we experience as fatigue, brain fog, or weakness. Here's the first critical distinction most people miss. Food is not energy. Food is potential energy. Before food can power anything, it has to move through a long chain of systems: digestion, absorption, transport, hormonal signaling, cellular uptake, mitochondrial processing. Only at the end of that chain does usable energy appear. So when someone says, "I ate plenty, why am I tired?" they're asking the wrong question. The question isn't how much food came in. It's how effectively the system converted it into ATP. This is where metabolism actually lives. Metabolism is not how fast you burn calories. It's how reliably your cells can produce energy on demand. A stable metabolic system produces ATP smoothly across the day. An unstable one produces it inconsistently. That inconsistency is what creates energy highs and crashes. Inside the cell, most ATP is produced in structures called mitochondria. Mitochondria take fuel and oxygen and convert them into usable energy. But they can only do that if several conditions are met. Fuel has to be accessible. Signals have to be aligned. Electrolytes have to be present. And stress hormones can't be constantly overriding the system. If any of those inputs are disrupted, energy production drops, even if food intake is high. This is why energy problems are rarely solved by eating more. More intake doesn't fix poor access. More calories don't override broken signaling, and more stimulation doesn't repair cellular dysfunction. Energy is not created by force. It emerges when systems are aligned. Another critical piece is fuel flexibility. The body is designed to run on multiple fuels: glucose from carbohydrates, fatty acids from stored fat ketones produced during fasting or low intake. A healthy metabolic system can switch between these fuels without friction. That switching ability is what keeps ATP production stable. When flexibility is lost, the body becomes dependent on constant intake. And when intake stops, even briefly, energy crashes. This is why some people feel shaky, irritable, or exhausted between meals. It's not weakness. It's metabolic rigidity. Their cells can't access alternative fuel efficiently, so ATP production becomes fragile. Over time, this fragility teaches people to rely on frequent eating, caffeine, sugar stimulation. But those don't fix the system. They just temporarily mask the output problem. Real metabolic energy feels different. It's calm. It's steady. It doesn't spike and crash. You don't notice it because it's not loud. And that's the point. When metabolic systems work, energy production happens quietly in the background. You don't need motivation to access it. You don't need stimulation to force it. Energy becomes reliable. So when we talk about metabolic energy, we're not talking about hacks or tricks. We're talking about whether the body can do what it was designed to do: produce ATP, maintain output, adapt to conditions. And that's the foundation. Every discussion about fasting, blood sugar, electrolytes, sleep, or stress builds on this single reality. Energy is not something you chase. It's something that emerges when cellular systems are stable,